Just a quick mic check. Everybody can hear me okay? Awesome, thank you. Thanks for coming out to check out my talk, Rips, Reps, and Revelations, creating cyber fire drills using Atomic Red Team to continuously test our team. So a little bit about me. I'm Paul Michaud. I'm a principal threat hunter at Red Canary. I have a background in threat hunting, purple teaming, incident handling, and incident response. I am a maintainer, one of the maintainers of Atomic Red Team, an open source library that we'll touch on here in a little bit. I also co-host a web series with my good friend Michaud. It's called Atomics on a Friday. Back a few years ago, Atomic Red Team had a webcast on Fridays called Atomic Friday, so we kind of brought it back in a different light called Atomics on a Friday. So we host it ourselves, so there's no vendors, there's no pitches, it's just talk and security with a bunch of people. So you can check those out. We stream to Twitch and YouTube. All the recordings are on YouTube. I have a cat. His name is C2. He is the softest cat ever. Our vet even said so. So it's clearly scientifically backed. I don't know how this works. There we go. There he is. He's definitely malware. We adopted him. His name was Kelvin II. So C2 just kind of fit in. Kind of just worked out that way. So it's pretty fun. You can find me on Twitter at burning_PM. So let's kind of overview of what we're talking about today. So what are we even doing here? How did this come about? Some background. And then we're going to go kind of into the steps. So using Atomic Red Team to actually execute the tests that we're going to identify why we're going to be testing. How do we approach this so that it's repeatable and simplistic? And then kind of some of the revelations, like what did we learn? And if you're a Letterkenny fan, you might recognize some of these things that I dropped in, as well as some pictures. So hopefully have some fun with that. So a little bit of background. Before threat hunting was a team, we actually recently just changed names, so not too much change, but we were the incident handling team. And a common misconception was that incident handling was kind of like incident response, and it's absolutely not. So if you're not familiar with Red Canary, we do managed detection response, so we identify threats, and then we tell the customers about it. Where the incident handling team stepped in was after that detection got published, we would tell you how to help guide and advise on remediation. What should you care about? How do you do it? All those types of things. So we never were actually hands-on. That changed a little bit. We had incident response partners, but we never did incident response ourselves. And we're kind of bridging the gap with active remediation. So these are things right before like things blow up and now you need to call IR. So this is allowing us to respond on your behalf. So using EDR platforms to go into live response or remote shell sessions and clean up those threats. So how does this tie in? Well, incident handling / threat hunting team was the one to go build out and implement active remediation. But that's now hands-on, and we weren't hands-on. So somebody like me who had a background as a security analyst, it's been a few years since I did hands-on remediation and responding to threats. And some people had backgrounds where that wasn't their thing. So we had to figure out a way of, okay, how do we learn the platforms to respond, but how do we identify and learn how to respond to threats themselves? So we had to learn the tool, but we also had to learn the skills and knowledge to actually respond to it. How do we do that? So the idea was, how do I simply and consistently provide the team, so the incident handling threat hunting team, hands-on response capabilities to develop those skills. So in a simplistic term, we had the team that had really good and could tell you how to respond to threats. We knew all the things to do, but now we just had to make sure that we could actually do them. So we had to go from this level and take it to the next level. So the solution that we came up with was kind of what we approached it with. It had to be simple. Anybody should be able to do this. I should be able to go to anybody on the team and say, hey, it shouldn't rely on one person to run these, but when we create these fire drills, we had to be able to give them to somebody. It had to be repeatable. So learning 8 EDR platforms and each one varying in their skill, what they provide, we had to take the test and be able to run it on both of those so we could identify like, how does the live response work on platform A versus platform B? What are my caveats? What are the things I have to pay attention to or limitations of that? The last thing is it had to be measurable. We had to have clear ways to identify that we are doing the right things and that it's growing the skills and knowledge of the team. So, well, let's jump into Atomic Red Team and figure out why it's going to be the solution and how we used it to actually scale it. So Atomic Red Team, if you're not familiar, is an open source library of security tests. They're mapped to the MITRE framework. The original idea of Atomic Red Team was we needed to identify data sources. So EDR what does it collect and how does it collect it, and then where does it go? So the test was, if I expect process execution to be logged, I run a test to create a process. If I expect files to be written to disk, and that's what I expect my EDR platform to do, endpoint detection response, and collect the files, I need to be able to see that. So this is where Atomic Red Team came in, and then now it kind of evolved into detection validation. So if I have an analytic that says I'm looking for PowerShell making a network connection, I should have a test that runs PowerShell making a network connection, right? And then it kind of evolved into threat emulation, and now we're going to kind of use it in some response training, maybe. So let's take a look at how Atomic is structured to understand how we can use this to build out fire drills to train the team to learn the tools, but also learn response. So the structure of Atomic is pretty simple. It's just a YAML file that has definitions of certain things. One of them being the name, like what's the friendly name? What do I call it? In this case, I'm going to create a local scheduled task. Each Atomic, when you merge a test into GitHub, there's a bunch of CI and CD magic that occurs, but each test gets a unique GUID. So tests can get rearranged, right? MITRE comes out with an update and says we have 10 new sub-techniques and a test has to get moved under a new one. The order of the test can change, the name of the test can change, but the GUID always stays the same. That is the unique identifier that I can always plug that in, and that test will run. The supported platforms, so we have tests that can run on Linux and Mac, right? Think like Python scripts. They're default, I can run those. Windows, and we also have support for cloud platforms, as well as like GCP, AWS, Azure, and even things like testing Azure AD. Then you have input arguments. These are custom variables that I can change and define. So when we create atomics, they're very simple things like atomic test 123 is the task name for a scheduled task. So we give you the ability to override those so you can actually emulate kind of what a threat does. And we'll kind of go into an example of that. Then we have the executor. What is the thing that is actually going to run this? In this case, it's going to be command prompt. And then elevation required. So there's some tests that require you to have an elevated command prompt. Think like something like a Mimikatz where I want to dump credentials. Standard user can't do it. Administrative system level, that's going to give me the access that I need to go do it. So it'll actually tell you like, do I need to be required or a higher permission? Then the actual command, and then cleanup. So one of the things that is like, you run the test, we also give the ability to clean it up afterwards. So it's, you spin up a VM, you run the test, you collect your data, and then you're off. So here's kind of another example, but now in the middle, what you can see is there's dependencies. So while like a scheduled task, very simple, run sctask.exe, give it the parameters that you want. There's some that say, hey, go download this file or make sure this file exists somewhere on disk that may not be there by default. So what these do is very similar, is they go and say, here's the prereq command, make sure that thing exists, and then if not, go get it and then put it there. And then everything else is still the same. So there's ways to say, hey, go validate it exists, and if not, go get it for me. So in some cases, you build custom things, like it may not exist, or you may have a variation to where you may not want like legitimate bad evil running, so you create your own. And we structure the tests, so in each directory, we have a source file, so things like the plain C files, if there's a bat file that actually compiles it on the fly, and then the bin. So the bin is the binary, so the actual compiled binary. And that's usually the thing that gets downloaded or is staged somewhere for the test. So that's the structure of Atomic. Now, some of those, you can just go to the Atomic GitHub repo, copy a test, paste it into the command prompt, and let it rip. But that's not really scalable, and if I want to run a bunch of these and do a lot of validation, we need a way to execute these. So we have frameworks, or executors, and the two most common are invoke Atomic Red Team and Atomic Operator, which is written in Python. And these are basically ways that our code to read the YAML, understand it, and then go do whatever it says to do. So we're going to focus on invoke a little bit, because that's kind of what we leveraged as we were running our test. It's cross-platform, so there's support for Windows, Mac, and Linux. So on Linux and Mac, it uses PowerShell core, and then on Windows, it just uses regular PowerShell. It does support local execution, but let's say I wanted to run a test on 50 endpoints. I can create a PowerShell session on 50 endpoints, pass that as a parameter, and then it will magically go out, create those connections, run the tests on all 50 endpoints, and then terminate the sessions. And the same works on PowerShell core for Linux and Mac, where I can just use SSH or Secure Shell. Some of the parameters we're going to focus on are input arguments and prop for input arguments, get prerequisites, and cleanup. So let's take a look at what it looks like when we import the PowerShell module. So if we go to invoke atomic red team, it's on a repository itself. We can then install it. There's a great wiki guide that kind of steps you through. There's like 2 commands that you can get in the executor framework and all the atomics. So it's like a one-liner. You just drop it in and it does the magic. So in this case, we tell it, okay, invoke atomic test is the module that's going to go run the actual command. We have the technique ID. This knows to go look in a specific directory in our atomics folder, and then it knows to read the YAML file inside of that. And then there's things like test name, where we can give it the explicit test name we saw earlier. In this case, I just use the test name, but we could also have like test GUIDs, so again, using those programmatic GUIDs, and then showing details. So basically, spit out in the command line, what are the things, and then what is it going to look like? So kind of in the middle, we can see like where we have those custom input arguments, kind of shows where they go, and then it'll spit out with inputs what's it going to look like when we actually run it. And then the actual cleanup command. So now let's look at something like getting prerequisites. So the prerequisites, again, are going to say, hey, do I have anything that needs to exist before this test to run? Otherwise, if I run it and that doesn't exist, it's going to fail. So in this case, we don't have any prerequisites, but maybe I want to override the defaults. I can programmatically write a hash table, which we'll look into, and override those and pass it as a parameter. Or I could say, hey, prompt me each input argument, and either I'll allow the default, or maybe, hey, there's one parameter that I do want to change, and it prompts me for that. And then the cleanup, again, I just pass the cleanup flag, and after execution, it will go and clean up anything that it did. So like in this case, create a scheduled task, it will go and delete it. So that's kind of the overview of Atomic, right? It's the structure, and now we have how they work, and now we have the executor of how we can actually do them. But now let's scale it. Let's create some scenarios that we can kind of come across. So when we're building plans, there's a couple ways we can start. So in like a traditional setting, maybe like in traditional SOC, we're trying to build up the team and build up and continuously make sure that they can respond, they have the insights, and we're doing it consistently. Sometimes what happens is we wait for things like purple team engagements or red teams or even tabletops, where that's the time where we get our hands on, we can do our thing, but then we wait maybe 6 months or a yearly thing for it to occur. But that's a long time, and it's not giving us, potentially, we forget all the things. So we want to provide ways that we can continuously do this in a simplistic manner. So in a traditional sense, we want to think about where our concerns. Is my team really good at responding to phishing? But maybe we get later into things like credential theft, where maybe they're not too sure of what happens. Like all of a sudden Mimikatz runs. Well, what does that mean? What happens? How do I respond to that? What are the things that I don't necessarily do on the endpoint, but things like resetting credentials? What did that user do, right? So some of that response capability, where you have different techniques that are going to require different responses. So we can think about, from a technique standpoint, or even just a full-blown attack path, what is that going to look like, and then how do we respond to it? So where can we pull inspiration from for creating plans? Well, we have things like threat reports, open source intelligence, and of course previous incidents, right? So previous incidents are a great way, especially internally, like if we did this and we didn't have a great response to it, that's a perfect example of build a plan, run it a few times, and every once in a while, maybe you throw in something different. And then how do we build it? Well, we're going to start simple, and then we're going to evolve it over time. As we watch and see the skills grow and change, we want to keep up with that. We want to make it a little more difficult. We want to inject some new things, maybe change it up. We're going to use a little bit of YAML and the invoke atomic framework, and then we're going to schedule it. So let's look at some ways that we approach this as we were testing our tools. So you have a basic execution flow. So we started very simple. So think of the nodes as a single thing that occurs. User opens Word, PowerShell spawns, makes a network connection, downloads a file, runs something else, and then maybe schedules a task, right? Very 1, 2, 3, 4. No hidden secrets, there's no gotchas, it's very straightforward, because we want to start to gauge, okay, this is the bare minimum, this is kind of the basic thing. Where are we at? Where's the team at? What occurs? What are some of the pitfalls we identified? Then after we do that a few times, we then approach it a little bit different. Maybe we start out the same, but now we change it so they don't just get complacent that I know that this is going to occur, then this, then this. So then I start to change it up. Then you get a little bit more interesting. Maybe I don't tell you how it got there. Let's say it evaded some defense, and I inject something different, right? And then I skip the next one, and then I give it something else. And I can plant those other events along the way, but I may not tell you about them or make sure that it avoids a detection or alert, so that you have to then, as the analyst, start to kind of piece it back together, right? I don't give you a full picture, right? Just in like an attack path, you don't know the whole thing to start. You know bits and pieces and have to build it over time. Then you can do something like we started to do, which was all attacks don't just stay on one endpoint. Sometimes if we're good enough and we detect it early enough and we respond quickly, we can contain it to that single endpoint. But sometimes you start off on one endpoint and then it goes and does something else on another, and then it goes back to a different one or the same one. So we start to get a little more complex. And this is like our evolution that we did internally as we were testing out the various platforms, building up the skills and knowledges. We started very basic, then we started to take that exact same flow, but we took away key components. And then we started to make it a little interesting and start to throw it across like 5 or 6 endpoints. So that's how we kind of built them out. But now let's look at an example of how we can take something like a threat report, build out an emulation plan, and use that as our example of our execution flow. So in this case, we're using a default report as a great example. So we're going to review for the potential of tests. So each one of these are going to be something that we're going to use along the way in our emulation plan. So the first few are things like disabling Windows Defender, creating scheduled task and downloading a file, adding a user account, and then adding it to local admins and remote desktop users. So just kind of high level, we're going to step through. So now what we can do is say, okay, in Atomic Red Team, is there a test for disabling Windows Defender? Great thing is there's probably about 25 of them. So we have our bounty full amount to choose from. Things like create a scheduled test. Well, we saw an example of that, but let's change it up. Let's tell it, instead of maybe launching command in that example we saw earlier, we now give it a PowerShell command that just goes and downloads a text file. Right? We don't need full real malware. We just need things that are going to mimic certain procedural things of a threat. And then so on and so forth. So let's look at an example. So this was kind of like the base thing. Again, I needed to run this for a team of 18 consistently across multiple points as we're kind of building out this new offering, right? So this is kind of stage one. Like, can I run this in PowerShell in a very basic, simplistic manner, which is provide an override. So here's an example, as which I mentioned earlier, is if you look at kind of the third line at scheduled task, the one below that, I'm not a PowerShell master or any means, but create a parameter called, I forget what that says, scheduled arg, and then create a hash table. So hash tables are basically allowing me to put in multiple key pair values and then pass that as a single variable into the command line. So in this case, the second one, so we invoke our atomic test, so that's our module. We have the technique ID, the specific GUID, and then we're going to pass in the arguments that we want to override. And what we do is we say, okay, well, the default is 2020, if I remember correctly. But I want that to execute sooner because it's going to go and run that PowerShell command. Then in the next example, we kind of borrowed this right from it, and it gets cut off. But what it does is I override the arguments to mimic the file names and patterns that were in the threat report. So now I'm procedurally trying to map what the threat actor did. So it's a little more realistic than just saying, here's a bunch of atomic, it's atomics everywhere, and we kind of all know that, right? Trying to get a little bit more realistic. And so we just step through. And so we're defining those custom input parameters based on what we saw in the DEFA report. So here's now how we said, okay, so that's great in a PowerShell script that works on one endpoint, but I need to do this on many endpoints so I can get more people hands-on in a faster capacity. So in this case, as we mentioned earlier, we can use PowerShell in order to create remote sessions. In this case, we're going to create a variable. We're going to tell it new PowerShell sessions and give it the computer names and then prompt me for credentials, and I'm going to put those in and then pass that along. So it's the exact same script from before, but now at the end, we tag in tax session is the parameter that we're going to use, and then pass in the session argument. And now when it runs, it's going to, at those specific points where I say session, it's going to go out and on each endpoint that I specified above, go and run that specific thing. So now I have not just one endpoint with the test, and I have to do this 3 times or 5 times, but I have 3 in one execution. Now, that's great, but again, I don't write PowerShell. I don't expect a lot of people to just be able to write PowerShell. So let's take that idea and let's put it into Atomic. Well, Atomic's written in YAML, so why can't I just write YAML? So this is what I did. So there's basic inputs that say like what the emulation plan is, what the description is, any references, and then so we specify the atomics, the technique, the GUID, and again, any custom input arguments. I can put them in there. I don't have to put them in there. So this is a very simple, basic YAML schema that I wrote for a wrapper script, which we'll jump into next. I'm just kind of identify it. So again, now what I did was make it so that I can take this YAML file, I can give it a PowerShell script, and then give it to anybody, or create 20 YAML files and say, here you go. So there's our repeatability without having to have anybody be an expert in PowerShell, but the ability to then just go and run these. So at the end, I have links to all the different things, but this is just the bare snippet of code. Again, I don't write PowerShell, but this is it. So basically, look for the YAML file, parse out specific points, do a couple checks. Is Atomic Red Team installed? Obviously, if it's not installed, we can't run anything, so we need that. Validate that there's prerequisites, so go get those prerequisites. Again, if we're going on remote computers, they may not have Atomic Red Team, and they don't need it. They just need those specific files to exist in those specific things where that test is going to want them. So automatically go put and stage those files for me or whatever, and then actually go through and run those tests. So Invoke was designed to run a single test at a time. So what I did was simply just said, okay, well, create a loop that however many tests are in the YAML file, just iterate through and then pass them over. So now each test is going to run, and I don't have to worry about manually running that. So not great, but it works, right? It solves the problem. So we're kind of there. So we have like a minimum viable product of I can write some YAML, I have a basic script that I can give to anybody on the team and say, go run these, create some fire drills for the team so they can practice their response. What does that look like? So in this example, again, point to the PowerShell script, point to the YAML file. It's going to run through. It's going to check for the, make sure that atomics exist, that invoke is there. Step through for any prerequisites. In this case, a lot of them don't have any. I think at the bottom there were a few more, but got truncated off. And then the next step is once that's done, go and actually execute it. So in this case, go execute the test, download the file, go create the new user, create the guest accounts with adding those in, and that's what the output gets. So that's it. That ran all the tests, and now what we should see is that whether we're in a case of Red Canary, we should see events, or in like a traditional SOC, you should potentially have a bunch of alerts starting to fire off. And that's the indicator for the analyst to say, okay, like now it's time to go. Like now, based on this, go clean up scheduled task. A new user was created. What is my response, and how do I respond to that? Right, and you may not know, and that's okay. So that's what we did. So we created a very simplistic thing that we could just easily repeat. When we started this, I was manually creating these tests by hand. So I was creating payloads, I was spinning up C2 servers, and I was blasting out. And it worked great in the beginning, but it didn't scale. And it, again, resulted in a single point of failure. So if I was out on vacation for 2 weeks, those fire drills weren't getting done, and it kind of hindered the team's ability to keep going. So what did we learn? So basically, we identified areas for improvement in knowledge. Again, we had a lot of different people that were in, like myself, who hadn't touched and actually done response in probably 3 years at this point. We had some people that never did. Like they came from a different vertical in the security industry where they kind of needed to build those skills. The basic response actions were easily picked up. So as we started these, things like isolating the endpoint or quarantining it, deleting files, killing processes, banning hashes and platforms, right? Kind of some of the basic things to at least get the containment going. Easy. What we also identified was there were specific techniques where knowledge or gaps started to show. And one example, right, like WMI event consumers. Sometimes that comes across, but more commonly things like a scheduled task is the most common to show up from a persistence, but occasionally things like WMI event consumers show up. Well, that was like a question. Well, what is this and how do I respond to it? And then again, our execution flows evolved over time. So we started out very basic, and we kept that going. So we did very simplistic flows. In the phosphorus example, a little bit more advanced that we did at the end. But again, we started with those things like word spawning PowerShell, downloading a file with a network connection, creating a scheduled task. We ran that over and over, and again, as we had multiple EDRs to support, we then ran that same test and identified where the gaps were and figured out how we can actually do it. So we would keep running the same test, and every few weeks we'd run the same test over, right? Like, we know what happened and where they were, so let's say 80% was done the first time. Well, hopefully the next time we do it, it's improved, right? Hopefully it doesn't decrease in our success rate, but it actually improves. And then occasionally we throw in a monkey wrench. So one time we created a really advanced thing, mostly for my fun and edification. We compromised the EDR sensor and basically injected into it, and so the security tool now became the threat, so what do you do there? Didn't expect anybody to actually do really well with this. It was more, again, just for fun, and just kind of walk through and like, what happens when your security tool gets compromised? What do you do in that case? So maybe that one time, it was a lot of fun for that one. So ideas for measuring success. I think it was an important key. And the idea was not to say like, well, we did terrible in this and we did terrible in that. It was, again, to baseline the knowledge, figure out where we need to spend our time and efforts, and so that we could then, again, build the skills. So things like triage actions. So based on this plan, as the creator, I know that there's going to be things like 10 files that have to get deleted. The endpoint should be isolated. These specific hashes should be banned, right? So we know kind of some of that initial triage things that we can start to do it. So if 10 of those existed, how did they do? Did they get 8? Did they get 7? Did they get 5, right? It's just like an initial triage. Then could they talk about the attack path? Like, how did it start, right? In the very beginning, doing the basic execution flow, A to B to C, right? It's pretty easy to pick up. But as we started to take some things away and leave breadcrumbs, did they pick up on it? Could they paint the picture in like a 2 to 3 sentence thing, or even in a 30-second spiel, tell me exactly what happened at a high level, right? Artifacts, again. What were the numbers identified? Because there's instances in our case where things like resetting user's credential, we couldn't do that, the platform couldn't do that, right, in EDR. That's something you go and do in like Active Directory or your identity platform. But are those things that we couldn't do but need to get done? Go pull the emails from the email people's inboxes, right? Go block the domains of the firewall, things of that nature that, again, you can't do necessarily from the platform, but still need to get taken care of. Then we started looking at like mean time to remediation, average time to remediation. We loosely kind of track this because not every threat was created equally and not every platform was created equally. So in our case, it wasn't really fair, because if we said, well, it took 5 minutes this time, but it took an hour and a half this time, well, why? Well, 2 different platforms, 2 different scenarios, 2 different problems. So we kind of loosely gauged it of like, how, what was the average time, knowing, again, some basic math. And then assistance. One of the great things about this is that we were divided into 3 teams with people on each team, is that nobody was just kind of left hanging. Pretty much they all spun up a Zoom and then jumped in, and there was probably like 5 people, 6 people on the Zoom, and so like one person was responding, but they could ask questions, they could, as they came across things, like they asked for assistance. Over time, how much assistance did they start asking? Or were they just able to go for it and kind of start to figure things out? So it's kind of an interesting way of just seeing like the collaboration and then where the growth is occurring. So in summary, so the idea was we needed to baseline the skills and knowledge. We needed a way to have a simplistic and approachable method to actually run these tests. And then we needed to make it repeatable. So what we did was we ran 6 tests a week. Again, we had roughly 17, 18. So we ran 2 tests on 3 endpoints. So basically, one day, on let's say Tuesday, we would run a test, it would be on 3 endpoints. So that gave 3 people a chance. The next day, on Wednesday, we would run a completely different test so that 3 more people could get in. And then we would spread over 2 days, and we'd have a debrief session. Spent like half hour, 45 minutes. Here's what happened. Like, here's any questions. Like, what did you guys think of? And again, so we're trying to track for success here. Again, it wasn't to see like, oh, you guys didn't do well in this, but it was just to see where we're at, understand the limitations of the platforms, put in our process and procedures so that we could know and effectively respond to those threats. But we can apply this into like a traditional SOC setting, right? You may not have 18 people. You may have 5 or 6. You may have 3. But you can take a report, you can run it, generate some events, and get hands-on so you don't have to wait for those things like the tabletop exercises to validate your process and procedures, or specific things that you may not come across every day, like cloud or identity-based threats. Because Common Pride can't do those, we can still spin those up. So here are some resources. So atomicredteam.io is the website. You can do some quick searching. There's the GitHub repo, the executor frameworks. So Invoke Atomic, and then Atomic Operators, actually from Swimlane, is the Python variation. Atomics on a Friday is the GitHub repo for the emulation tools for the YAML files. I'll share this out. It's also publicly available. So some inside scoop. There are some new features coming and functions within Invoke that are going to support and actually be able to natively, so you don't have to download like a wrapper script. And there'll be a standardized YAML schema, so we can actually build out a lot of emulation plans, have a single repository that are open sourced emulation plans, and then a built-in parameter for actually running these. So you don't have to have like 10 things, consolidate them all, make it really easy, right? Atomics are there, why not the emulation plans, and why not have an executor framework like Invoke and Atomic Operator to just natively run these. So that's going to make it a little bit easier. So that's in the pipeline, some inside scoop. So look forward to that. And that is it. So thank you all for coming and letting me ramble about some of the stuff that we did. Any questions? Yeah.
So right now you have a way of querying other machines in the group. Do you have any way of getting a response back from those? Like when you send out and you open up a PowerShell and run testing on your remote machine, do you have a way of telling that that was successful or not successful?
Yeah, great question. So is determining if I run a test, is that test successful, especially when I have, not necessarily locally, but on remote machines. So there is a logger or function built into Invoke and as well as operator. It doesn't necessarily always in certain tests tell you that it was successful or not because there's no way to explicitly query for that. So some tests do have that capability, but some don't. And some tests, it just kind of hangs, it will potentially crash, and then you have no way. It just says, hey, I ran it, and that's kind of it. So there are some cases where, yes, you do have that capability, and some that you don't. And then there's other tools out there that actually have that capability where it'll actually run the test and then it'll basically just like query like, okay, is that process running? Cool, and then over time terminate it. And there is some functionality built into Invoke that says, hey, have a timeout. So if I expect the thing to run and it's not terminating, like go terminate it, right? Like as part of the cleanup process. But it won't explicitly say like yes, successful or specifically no, not in some cases, just because of the way that certain tests run. Good question. Yes.
I assume you're running this in your high-graded test range. What about customers? Is the expectation that they're running it in their ranges as well?
Yeah, so so the question being, how do customers run these or where are they running them? So basically spin up a VM or spin up kind of a lab. While most of the tests are very benign, while they're not necessarily running malware, you may not want Mimikatz running on like a production workstation, right? So you kind of spin up a few tests in that capacity. We have customers that use these as like, again, in the traditional sense of what it was built for was data source validation. Did I expect out of 20 tests that on 20 machines that I had a logging for process execution, file writes, network connections on my test? Did I get all 20, right? So in that sense, and we have cases of, we have customers that are in the small business and medium business that don't have like a full security team, but are like, hey, if I got hit with Qbot, what does that look like and where are my tools? They may not have like everything centralized, but you can still effectively go look at AV, EDR, endpoint logs, event logs, etc. So you could actually run this and go validate, like, did I see this? Did it get stopped? Is it exactly one-to-one like potential malware or threat actors? No, but is it giving you at least a starting point and kind of bridging that gap of going, the crawl, walk, run aspect? Sure. So there's that kind of aspect as well of like how people are using it. So there's kind of variations. So hopefully that answered your question a little bit, kind of
Yeah,
weird.
I think the end user of this needs to have some type of admin rights to the device, right? So if they're using Microsoft Defender, they'll have to disable it if they're installing some of the scripts. They'll have to basically hold it before they extract the stuff.
Yeah, so great point about like excluding certain things. If you run just Defender for Endpoint at home on your laptop and you clone the atomic repo, Defender is going to start lighting it up. It catches pretty much all of it. And a lot of EDRs and AVs do. And again, that's more signature based of things like there is a Mimikatz binary in there. There's things like SharpHound. So these different tools that necessarily by themselves aren't malicious but can be used in malicious capacities that it will pick it up. So there are cases where you may have to tune prevention tools, but that's also a good test, right? If I run this tool and I expect my thing to block it, did it actually block it? If not, why? Right? We all have that golden image, and here's the image, and I deploy it out, and I expect it to work, but we all know once you deploy it out 1,000 times, that may not be the case on all 1,000 systems, so it's kind of a good test of not only detection and collection, but are my prevention tools working as I expect it, and kind of see that from there. Question. Any other questions? Anything else that can happen? No? Awesome. Well, thank you all again. If you have any questions on Atomic Red Team or just want to catch up, I'll be hanging around for a little bit. Thank you again for coming out and letting me chat. Appreciate it.